no strangers to running private clouds in our home labs, but it's been a while since we looked at one here on the channel. So let's remedy that. This time, we're going to take a look at Canonical's MicroCloud and see what it has to offer for the home lab. Let's do this. Hey there, home labbers, self-hosters, IT pros, and engineers. Rich here. A short while back, Canonical, the makers of Ubuntu, reached out to see if I'd be interested in collaborating with them on their MicroCloud project. Canonical's MicroCloud is a lightweight, self-hosted, production-ready cloud platform built on top of Ubuntu. It bundles LXD, MicroCeph, and MicroOVN into a single automated stack, giving you high availability compute, storage, and networking without the complexities of OpenStack or Kubernetes. In short, it's your own mini cloud powered by Ubuntu, designed for the edge, home lab, or enterprise use. Here's the disclaimer. Canonical is sponsoring this video. But I have to say, and this is a first, Canonical has asked that I create this video as I would any non-sponsored video, positive and negative opinions included. So with the official disclaimer out of the way, let's get down to business. Let's start with a quick background on what MicroCloud is, how it works, and who it's for. Let's get to it. First up, what exactly is MicroCloud, how does it fit together, and why should you care? At its core, MicroCloud is a lightweight, production-ready private cloud stack built by Canonical, the folks behind Ubuntu. They describe it as a low-touch, open-source cloud solution purpose-built for scalable clusters and edge deployments. Here's how it works under the hood. It bundles three major open-source components: LXD for virtualization and containers, MicroCeph for distributed storage, and MicroOVN for the networking layer. With just a couple of commands, you can snap install everything, run MicroCloud init, and after answering a few questions, you've got your own MicroCloud up and running. MicroCloud can even be run as a single host for testing, and when you're ready to go to production, adding additional nodes for redundancy and high availability is as easy as joining them to the cluster. Why is this interesting? Because it gives you many of the features of big cloud infrastructure like compute, network, storage, and multi-tenant access, but it's packaged for smaller, remote sites, edge locations, or home labs where you don't want the full complexity of something like a sprawling OpenStack or Kubernetes build. To sum it up, MicroCloud is an open-source private cloud platform built for simplicity, automation, and smaller deployments. A complete compute, storage, and networking stack ready in minutes, and it's fully part of the Ubuntu ecosystem. Or at least that's what the marketing says. So let's find out if it lives up to its promise. The next step here is to walk through the deployment process and get it up and running. For this, I'm going to be deploying it on physical hardware in my home lab on my test box I built for just this purpose. Before we kick off the install process though, let's talk about the hardware requirements to run it. Let's get the requirements for MicroCloud out of the way first, starting with the minimums. MicroCloud requires a minimum of 8 GB of RAM per node. For storage, MicroCloud requires at least one local disk per node, which must be free of any existing partitions. For networking, at least one network interface is required. And the system must be running at least Ubuntu 22.04 LTS or newer. This is the same for both the minimum and recommended requirements. Now, let's talk about recommended production requirements. Canonical recommends at least 3 physical nodes for a production high availability cluster. For memory, 32 GB is recommended per node in production. For storage, it's recommended that you have at least 3 separate physical disks per node. One for the OS installation, one for the local node storage, and one for distributed storage in the cluster. Canonical recommends NVMe disks for storage. For networking, at least 2 dedicated network interfaces per node. One interface for intra-cluster communication, and one for uplink and external network access. On top of the 2 interfaces, it is recommended that each connection be at least 10 gigabit or higher for high performance and low latency. A few more notes about the recs here. First off, technically, you could create your entire MicroCloud cluster as VMs inside another hypervisor, which would be fine for testing or development, but absolutely not okay for a production environment. Basically what I'm saying is, in a production scenario, MicroCloud should be deployed on bare metal. Also, if you're going to go production, it'd be smart to separate out your Ceph public and internal networks and OVN underlays even further for the best performance. For a smaller scale deployment like I'm about to do, 2 10-gig NICs per node is perfect. But if you're planning to really scale up your cluster, you're going to want to pay closer attention to your network architecture, just like you would any other large cluster design. Now, let's plan out our deployment. Based on the recommended production requirements, we're going to need to plan out a few things first. Each NIC will have 2 10-gig NICs and at least 3 drives each. On the NIC side, one of the 10-gig NICs will uplink to my LAN, and the second NIC will connect to a layer 2 only network for dedicated cluster functions and Ceph traffic. The best way to work through this is with a simple worksheet. Let's take a look at that now. I think it's important that we take a moment to write down the network configuration for the nodes that will be used in this MicroCloud deployment. Here's my quick worksheet for making notes on what IP addresses and interfaces will be used for each node in the cluster. Here you can see the addressing I'm going to be using on each node. Having these numbers prepared now will make the base installation and configuration of Ubuntu 24.04 quick and easy. Alright, let's get to the installation. I'm not going to walk you through the base install of Ubuntu Server 24.04, which is why I took the time to show you the network configurations just a bit ago. So if you're following along here, you'll need to have Ubuntu Server installed and complete with your base network configurations before proceeding with the MicroCloud installation. Assuming you're there, let's move on to the installation now. Alright, let's walk through the installation of MicroCloud on all of our nodes and get our cluster built. What you see here are 4 separate SSH sessions into the 4 individual nodes that I'll be using in my cluster. I've named them MC-Phi-Node 1, MC-Phi-Node 2, MC-Phi-Node 3, and finally MC-Phi-Node 4. These are just their host names, and you don't need to have DNS entries set up for your hosts. Using IP addressing to connect is just fine. The first thing we need to do is install MicroCloud, MicroCeph, and MicroOVN via snap on each host. To do this, we'll run the command you see here on all 4 hosts, hit enter, and wait for the snap installation to complete. The next step is to configure the host to never update MicroCloud, MicroCeph, or MicroOVN automatically. The reason we need to do this is to make sure that all nodes in the cluster stay the same versions at the same time to prevent issues in the cluster. This doesn't mean you don't update these services. It just means you need to manually update them together at the same time. To do this, we'll run the command you see here. Alright, let's get our first node configured in our cluster. To install MicroCloud on our first node, we'll enter the command sudo microcloud init and press enter. We're first asked if we want to set up more than one cluster member. I'm going to say no here because I want to show you both how to set up a single member cluster for testing, and then we'll add the other 3 nodes to productionize our MicroCloud cluster. I'll type no here and hit enter. Now we're asked to select which physical network interface we will use for internal cluster traffic. If you remember from the worksheet a bit ago, you can see those addresses I had listed here. Our internal interface is on the 10 network, so we'll arrow down, hit space to select the 10 network, and press enter to move on. Now we need to configure our storage for our node. Each node will have dedicated local storage and shared storage for VMs and containers. The first stop is to set up local storage for this node. We'll leave the default as yes and hit enter. We're now provided a full list of all the available storage I have in my node. I have 6 drives in the system. Your configuration will be different. Just remember, for production, you need at least 3 total drives in each node. I'm going to select a single drive for my local storage using the spacebar to select it, and then I'll press enter. Next, we're asked to wipe the selected drive to prepare for use with MicroCloud. We'll hit the spacebar to select it and press enter to allow the drive to be wiped. Now we need to set up our distributed storage. We'll leave the default here and press enter. I'm going to select 4 drives to be used for my distributed storage using the spacebar to select and the arrow keys to move down the list. Once I have all of the drives I want to use selected, I'll press enter. Once again, I'll need to select these drives for wipe as we did with the local storage option using the spacebar and arrow keys, and press enter. Alright, you're going to see an error message here, but don't fret, this is expected. What this message is telling you is that we currently have no redundancy for our shared storage in case of node failure, which is correct, we only have a single host at this moment. This won't be a concern once we've added my other 3 hosts. So we'll enter no to the change disk selection option here and move on. We're now asked if we want to encrypt our selected disks. This is a personal decision that you'll need to make, but I'm not going to do it. I'm not concerned with encrypting my data at rest here in my HomeLab, so I'll leave this the default and hit enter. Now we need to configure Ceph for distributed storage, so we'll hit enter. Alright, we need to select the network subnet that we'll be using for Ceph's internal traffic. This traffic should go over our 10 network because that network is specifically for cluster communication and storage. The configuration already suggests that we use that subnet since I previously chose it, so we'll leave that the default and press enter. Now we're asked which subnet we want to use for Ceph's public traffic. This again needs to stay on the 10 network because I don't want anything to have access to Ceph on my LAN. Again, we'll leave it the default here and hit enter. We're greeted by a warning related to distributed networking. Don't worry, our networking will be fine. Hit enter to move on. Now we sit back and wait for MicroCloud to initialize its new services and become ready. This will take a bit of time depending on your hardware. Alright, done. If you only have a single node in your cluster, you're done and you can start working with your MicroCloud. We, however, are not done. We have 3 more nodes to add to our cluster before we're complete. Let's get to that now. Before we attempt to add our additional nodes to our cluster, we need to tell the single node to listen for others to join. To do this, we'll use the command sudo microcloud add and hit enter. Okay, let's add our additional nodes to our current cluster now. On each node, we need to enter the command sudo microcloud join and hit enter. On each new node, we'll need to select the interface that is connected directly to our MicroCloud's internal traffic network. Again, for me, based on my IP addressing, that's the 10.10.10.x network. So we'll select that interface for each node by using the spacebar and the enter key. We're now asked for the super secret passphrase to join the cluster. That passphrase was generated when we ran the MicroCloud add command on the existing node. Let's copy that passphrase, paste it into each one of the nodes, and hit enter. Now, over on the first node, we can see each of the new nodes is now listed with their addresses ready to be configured. So let's select all of them using the spacebar and hit enter. We'll be configuring the nodes from the first node, so we'll leave their sessions active in the other windows while we complete the setup. Alright, now we're asked if we want to set up local storage. Again, this is for the new nodes we're adding, not the previously completed node. We'll leave the defaults here and hit enter. Now we get a giant list of all the drives available on all the nodes. This can get busy here if you have a lot of drives and you're adding a lot of nodes. We need to select a single drive on each node for local storage, so I'll select one of the drives from each node using the spacebar and press enter. And, like last time, we need to approve the wipe of these drives to be used, so we'll use the spacebar to select them and hit enter. Again, like last time, we now need to select the drives we want to use for our distributed storage. We selected 4 drives from the first host, so we'll select 4 drives from each node as well, and hit enter. And now we'll select all the drives for wiping and hit enter as well. Once again, we're asked if we want to encrypt the drives. We didn't the first time around, so we'll leave this the default and hit enter. Again, we're provided with the distributed networking warning. We'll hit enter to continue. Alright, now the new nodes are being configured and added to the cluster. Again, this can take a while until the process completes. Boom, just like that, our cluster is ready. From an installation standpoint, the actual installation and configuration of MicroCloud was pretty painless, so thumbs up for that. Just to be clear, we could have set up the entire cluster all at once during the initial setup, but I wanted to show you guys how you could run a single node cluster in the case that's something you wanted to experiment with. Now let's talk about how you manage MicroCloud from a GUI perspective. MicroCloud doesn't have a dedicated GUI. Instead, MicroCloud leverages the LXD UI since that's one of the core components of the system. So with that in mind, let's take a look at the LXD UI now. All nodes in the cluster have the GUI, and you can access the UI from any of them. So pop a browser of your choice, and in the address bar enter an https:// your node's IP address or hostname if you set up DNS, :8443, and press enter. The site uses a self-signed certificate, so you'll need to click through to the website. The LXD UI uses certificate-based authentication, so we're going to need to configure that to access the site. Select the first cert in the list and press OK below. The next step is to generate a trust token for the certificate we just selected. To do this, we'll need to copy the command listed above and pop back over to an SSH console on one of our hosts. Now we'll paste in the command and press enter. Next step here is to copy the newly generated token and then head back over to the website. Now paste the token into the open text box and click connect. Boom, we're in. You only need to do this once per browser. Alright, the GUI is broken down with navigation on the left and context on the right, like you'd expect. MicroCloud features multi-tenant functionality, which they call projects. On initial deployment, a default tenant is created, and you can create more to segment out your workloads as needed. On login, we land on the Instances section. Instances are your workloads. They can be VMs or containers. This is a fresh install, so obviously I don't have any instances set up currently. We'll create one here shortly. Moving on. Profiles are collections of configurations for instances. Profiles allow you to create standard hardware configurations that will allow you to automatically deploy an instance without having to manually configure storage, CPU, RAM, network connections, and more every time you create a workload. Profiles help speed up deployments and standardize configurations. Now on to networking. The networking section is broken into networks, ACLs, and IPAM. The networks section is where you manage how your instances connect to each other and the outside world. You'll see bridges, VLANs, and OVN networks here. Each network defines its own subnet, gateway, and DHCP settings. This is also where you attach ACLs, manage peering, or link networks to specific interfaces. Next is ACLs. ACLs are applied at Layer 3 and Layer 4 and basically act like firewall rules to control what traffic can come in and go out of your instances. You can create an ACL, set rules for ingress or egress, and attach it to a network or individual NIC. It's all handled at the OVN level, so filtering happens inside the virtual network itself, not on the host. Moving on to storage. Storage pools are where all of your instance disks and volumes actually live. Each pool can use a backend like ZFS, LVM, Ceph, or even a simple directory. From here, you can create new pools, manage volumes, and see what instances are using them. Volumes are individual chunks of storage inside your pools. You can attach them to instances, move them between hosts, or use them for backups and data sharing. Think of a volume like an external drive you can plug into any container or VM. Custom ISOs enable you to upload your own installation media such as Windows, BSD, or custom Linux installers and use them to create new virtual machines. You can upload an ISO, launch a new VM from it, and install the OS just like you would on physical hardware. Buckets provide S3-compatible object storage directly within LXD. You can create a bucket within a storage pool and then access it using standard S3 tools or APIs. Perfect for backups, app data, or sharing files between instances. The Images section is where all of your base system templates live. You can launch containers or VMs directly from these images or upload your own custom ones. LXD can automatically refresh remote images so they stay up to date. We'll talk more about images when we build our first instance. Now on to configuration. Remember, projects are effectively tenants or namespaces that isolate resources from others outside of it. This configuration section allows you to customize various aspects of your project for your needs. Now let's take a quick look at clustering. First off, the Members section. The Members section lists every node that belongs to your LXD cluster. It shows details like each member's name, address, role, and current status. The start and stop functions on the far right allow you to manage your node's function in the cluster. For example, if you needed to reboot a node in your cluster, you would use the stop button to command the node to evacuate its workloads to other nodes in the cluster and move off any roles it currently is responsible for in the cluster. Once completed, you can reboot your node and use the play button to rejoin the node to active duty in the cluster. Groups let you organize your cluster members into logical sets. For example, maybe you have dedicated GPUs in a few nodes and you want those nodes to be managed separately from the other nodes in your cluster. You can use those groups to target individual operations or scheduling to specific groups instead of individual nodes. Operations show you the list of active, ongoing, completed, and failed operations in your cluster. If you had running tasks like migrations or downloads of images, you'd see them listed here as well as previous operations that it executed. Similarly, the Warnings section shows you any warnings or issues with your cluster that need your attention. You can find those warnings or issues here, deal with them, and then clear them once resolved. Now on to permissions. Identities is the first stop within permissions, and it allows you to manage all identities you've added to LXD. We created an identity when we first connected to the LXD UI, selected a certificate, ran the command to create a new identity token, and entered it into the system. Here you can modify an existing entity, create a new one, or delete one. Next is groups. The Groups section allows you to create groups to hold entities and then assign rights and permissions to those groups RBAC style. By default, I have just the admins group, but you can create groups and limit permissions to anything you'd like inside LXD. Last section in permissions is IDP groups. IDP groups come from your external identity provider like LDAP, Active Directory, or OpenID. They let you map existing user groups to LXD roles and permissions so access is managed automatically through your central directory. Configuring your IDP is done through the server configuration section. And finally, settings. Settings contains all manners of different settings that affect the cluster. There is a lot here, and it's not my intention to do a deep dive, but feel free to tell me in the comments if it's something you'd like to see. I will stop at one section though, and that's all the way at the bottom. The UI does have a dark mode setting you can enable if that's your jam.
Alright, we've done the install, the configuration, the UI walkthrough. All that's left to do here is to show you what creating an instance is like and then talk about the platform as a whole. Let's do this.
Creating an instance is incredibly easy in MicroCloud, possibly the easiest I've experienced in a private cloud so far. Let's walk through it. To start creating an instance, we'll click the Create Instance button on the right. First stop is to give our instance a name. The name field has limitations on the use of special characters and absolutely no spaces are allowed. I'll call mine Linux-test. Next is the description field, which is optional. I'll toss in my first test system in MicroCloud. Now we get to what I think is really the best part of building workloads in MicroCloud, their images. Let's click Browse Images to see what I'm talking about. Canonical has a truly massive list of available Linux images to choose from. And it's not just Ubuntu, though they have every possible flavor going back to 1604 LTS. I'd be shocked if you couldn't find your favorite Linux distribution in the list. The list contains VM images, container images, server, desktop, you name it. It's truly impressive. Let's head back to the top and select Ubuntu 2404 LTS and move on. The image we chose can be deployed as either a container or as a full VM, and the choice of how it's deployed is entirely up to you. We'll leave it set to container. If you had multiple cluster groups, you could select the group you'd want to deploy the instance on, but we only have the single default that contains all nodes. Remember when we talked about profiles? This is where you'd select a profile for your instance. I have a custom profile I made called Rich's default profile that only has a single change, a larger hard disk, so I'm going to choose that one. On the left side, you can further customize your instance if you want to add more network connections, disks, additional devices like USB interfaces or TPM modules, as well as make other custom settings. But for the sake of simplicity, we're just going to hit the Create and Start button to kick this off. Now we can watch the instance be built. MicroCloud downloads the image we chose for the base OS and completes the instance deployment. And done. Let's take a look at our deployed image. At the top of the right pane, we have the instance status and familiar controls like start, restart, pause, and stop. Over on the left, we have a button to force a manual migration of the instance to other cluster members, migrate an instance's storage, and move an instance to a different project. You can also create an image of the instance when powered off, copy an existing instance, export it out of MicroCloud, and delete it. On the Overview tab, we get details about our instance like base image, type, network addressing, architecture, cluster node it's running on, as well as memory and CPU usage stats, and more. Under Configuration, you can manage and modify the hardware configuration of your instance. You can add disks, network interfaces, manage GPU pass-throughs if you have them, set up a proxy, and add additional hardware depending on what type of instance it is. You can also set resource limits, security policies, manage snapshot behaviors, migrations, manage how and when the instance boots, and you can modify the cloud init used to build the instance. Snapshots allow you to create and manage snapshots for the instance. Terminal gives you direct shell access to your instance. This is essentially like SSHing into your system, and it's not the same as the console, which can be used for graphical access. You can run commands, check logs, or troubleshoot instantly without leaving the UI. Console is the true console of the functioning instance. If this instance ran GNOME or Windows, this is where you'd interact with that GUI. Finally, Logs gives you access to view the LXD logs for the deployed instance. Super useful if you're trying to troubleshoot something that didn't go right with your instance or deployment.
Alright, so let's get to my final thoughts here on Canonical's MicroCloud. Remember, Canonical said they wanted honesty, so let's start with the good. I've had my hands on a few different private cloud stacks by this point, and MicroCloud was the easiest to deploy so far. I am impressed. The fact that you're just asked a few questions and your Ceph, OVN, and LXD are up and running and working is fantastic. I like that you can continue to grow your cluster over time, and adding additional hosts is done with a single command and you're walked through the setup. I also appreciated the simplified user experience and interface. I've seen some very involved private cloud UIs, and MicroCloud is not that, which is a good thing. I'm not saying you're never going to have to go to the command line to do things, you likely will, but out of the box, so to speak, that's not necessary. I also really like the fact that, again, out of the box, you have all of these LXD images available for deployment. It's basically every available Linux system you'd possibly want to run. Yes, even Arch and Nix OS. It is the largest catalog that I've seen of images by far. Also, you can run Windows VMs on this thing as well, and they have a walkthrough on how to do that. I love the fact that it supports pass-through for GPUs, USB devices, virtual TPM modules, and even entire PCI devices easily through the user interface with minimal effort. Overall, I am very impressed with Canonical's MicroCloud. It has all the features you'd expect from a big, heavy private cloud and virtualization platform, and they've taken a ton of the complexities of Ceph, OVN, and LXD out of spinning up a cluster. It is definitely a great platform for your home lab or even for your business. So let's talk about the not so great. Let's start with the documentation. Canonical does not make it easy for an average person to follow the docs and get this installed, which I find ironic because the actual installation of MicroCloud is actually incredibly easy. A big part of this video's turnaround time was just trying to understand the initial documentation. I got through it, and it gets better later on, but especially in the beginning, it's not great, and that's a problem for adoption. There's also no built-in cluster statistics or graphing out of the box. The answer for this is Prometheus for collection and Grafana for displaying metrics about the cluster. And that's great, but I don't like the fact it's not built into MicroCloud itself. Most virtualization or container systems provide at least minimal at-a-glance health statistics and graphing, and I think having to spin up and maintain a separate monitoring stack in addition just to monitor your cluster is annoying and a missed opportunity. I also want to touch on the permissions and login approach Canonical has taken for accessing the GUI. In the world of IT, we all agree that certificate-based identities are incredibly secure. However, as a home labber, I'd also like to have the ability to use regular user and password authentication for the LXD UI. Specifically because I access my stack from a variety of different systems, including mobile devices like my phone. And having to manage certificates across those devices or manually register different browsers via the terminal isn't an enjoyable experience. And I will say that this is the first private cloud I've evaluated that doesn't have that out of the box. But for the few complaints I have, I think they're minor compared to the value add that MicroCloud provides. So if you're looking for an entirely open source private cloud that will run your entire home lab, VMs, containers, and all, check out Canonical's MicroCloud. Setting up and running a private cloud doesn't get much simpler than this. Special thank you to Canonical for partnering with us to bring MicroCloud to our audience and for giving me the opportunity to kick the tires and take it for a spin. You can find out more about MicroCloud and get started by heading over to https://canonical.com/microcloud. Let me know what you think of MicroCloud, the content, and more by leaving a comment below and join our Discord community. Thanks for watching, and we'll catch you on the next one.